So this is my presentation, BIFROST, how to not write a C2. So who am I? My name is Nikirk. I am a second-year computing security major, currently in the BSMS program. I am the WESIS president, WESIS at RIT, 7 to 8 p.m. on Wednesdays. You guys should come. I am the ops team cloud lead. So I run the GitLab and the CTFD. I am the offensive academy security mentorship group lead. I love to red team. I love Linux and Vim. Thank you, Sarthik. I love table tennis, and I worked at an FFRDC this summer, MITRE. Had a very good time there. So a bit of a backstory. Take you back 1 year, baby freshman. I was going to red team recruiting, working every single week, trying to build my little dinky little red team tool. I had little to no Linux knowledge or dev knowledge in general. I hadn't really written software before, besides my intro to CSEC classes. So GCS 123, 124, if you're a freshman, you're taking those right now. So I wrote my first tool. It's not my finest work. We're going to look at it in the next slide. So we see right here, there's a massive, massive while loop. So do we see any issues with this code? Just show of hands, people. Feel free to shout out. Oh, it's goated. It's very monolithic. It's basically just one function. That's not where you want to be at, honestly. And so what about functionality? Does it have encryption, group commands? Can you have multiple red teamers working on this tool? Is there a command history? So if I want to look back in time, to what I inputted, can we see that? Is there any logging? Well, we have ASCII art. And there was actually no encryption on it. So if you looked in Wireshark and you went to the packet capture, you can see the data going across just full plain text. So here I'm just running the command, who am I? You see that in Wireshark. That's not where you want to be at. So let's try and write something good. So I was at ISTS, which is one of our competitions, and I was with this red teamer. He's graduated now. His name's Jake. And he wrote a really cool C2. You can see a picture of it right there. It's a Flask app with a DB backend with a cross-platform compiled agent. And I'm like, this is really cool. I want to write something similar. It doesn't have a while loop that's going to the sky. So this must be pretty good, right? So I was very passionate. I wanted to do a lot of dev. I want to make something nice. So I started working on it. And if we look at the commit frequency here, we can see some clear issues. So Friday night, 33 commits. Saturday 6, 0, 0, 0, 0. This is not how you want to run a project. You find that if you are doing this pretty consistently, you're just going to burn out. It's not going to be good. 1 hour a day versus 12 in one day is actually a lot better. Give yourself breaks to do your stuff, review, sleep. That's important. Obviously, it's too much in one day. And yeah, that's a real photo of me that Sunday. Yeah, laugh. So how to not burn out? Like I said, work consistently. Sleep. This will be a major tactical advantage of your average red teamer. They do not sleep, so if you sleep, you'll write better software. It's just true. Use a calendar. That was something that really helped me out. Blocking out specific times where I want to do dev versus just regular fun stuff. And having something like a free day, for me personally, helped me out a lot in terms of not burning out. Just so I'd have some time set aside to where I could not have to worry about dev, not have to worry about homework. I could just be me. So what about my dev organization, right? I messed up all this other stuff. What about that? Well, if you look here, you can check the repository, Nikirk/BIFROST on GitHub. You can see about 130 of those commits were directly to main. You may see no issues with this now, but work on a larger code base. It starts to get pretty messy. So what should I do instead? So here's the typical dev cycle. This is what I found works out very well for me, and you'll see this is pretty standard. Basically, you make an issue. So there's this bug, there's this feature I want to add, there's this enhancement. Make an issue in GitHub. You can literally just open one up in the GUI. It's super cool. You can make a pull request, and you can actually have that pull request aligned to an issue. So It's kind of hard to read, but you'll see like number 11, PR. That actually maps up directly to an issue that I made. So it's very easy to keep track of everything that you're working on in the project. So you make a PR branch, you add your commits, you do a code review. This sounds really weird, but you're going to review your own PR. Sometimes if you're working on this very late at night, which you probably will be, you shouldn't, you'll write some really odd shit. And so I would recommend looking over your PR, making sure that your code is fine, and eventually merge into main. Following that, you will bring down production or something like that. So dev/project organization. What was I talking about earlier? You saw that massive list of PRs. There are these things called milestones. Basically, it's just a major version hit in your project. So breaking things down into individual problems and then solving them like that can be really helpful, especially if you have like a large feature or an issue that you need to like solve. It can be just very easy to like break it down into individual steps so you can then solve it. And also be specific. So if you want to add something to your project, let yourself know exactly what you want. Looking back, like 2 months, I look at some of my old commit messages. I have no idea what was going on. So be specific. Other people are going to be reading your stuff. They will have no idea what's going on. You will have no idea what's going on. So a bit about helping yourself. Automate things. I cannot tell you how many times when I was working on this where I ran 7 commands in a row, would do a bunch of dev, run 7 commands in a row, do a bunch of dev, repeat, repeat, repeat. Instead of doing those 7 commands, why don't we just do 1? So something I found that really helped me out was having a makefile. This was kind of co-opted by like DevOps community. Originally, it was used to make C stuff and compile C programs. However, it's a very, very useful automation tool. So see right here, I have make deploy, make dev, make init, make test. Those are all very useful actions that I was doing a lot of times. And I wanted one central place where if I was working on my code, I could very easily perform an action that I was doing a lot of times. So what's that about testing? We saw make test earlier. Yeah, you should have tests. This is a really great quote by Robert C. Martin that I'm going to read out. Why do most developers fear to make continuous changes to their code? They're afraid they'll break it. Why are they afraid they'll break it? Because they don't have tests. Test your code, please. So basically, TLDR, testing allows for fast development. You will find that when you're writing tests, you actually push changes faster. The reason is because when you mess up something, it is extremely clear when old code is broken. And you get this sense of security as well when you have fully tested code that's going to work in production every single time. Also, never deploy untested code. I've seen this happen before. It just leads to a whole bunch of issues. You don't want to do it. So the other big piece that I haven't talked about, documentation. So there's actually more wrong with this initial code snippet than we thought. I have no idea what it does. Honestly, looking at it, I'm like, I don't even know. There's like 4 if statements. It's all nested. There's no documentation. There's something that says interact with shell. So I'm assuming this was like some like CLI tool, but I have no idea what it does. So document everything in a consistent way, in a consistent style. You don't want to be using different commenting styles in the same piece of code. It just looks bad. It's hard to read. So indeed, ratio of time you spent reading and writing code is about 10 to 1. You really, really, really need to make sure that your code is readable because when you get to a larger project, you're going to be having other people work on it as well. If they don't know what you're doing, they're not going to want to contribute to it. So make sure you're also not going to want to contribute to it. That's a big point. If you can't read your code, you're just going to scrap it. So make sure that you're commenting it well. So let's look at something nice. So this is the documentation for Bifrost. This is not what I originally had at all. This is actually built using 2 free tools, read the docs, and there's this like Sphinx generator. You can look those up in your own time, but see how it's like very easily organized. We have full documentation for each of the commands. I'll actually show you what this looks like in the code because this is auto-generated straight from my source code. And I have a clear idea of what everything does. So, builds the binary using the provided values. That's pretty simple. All of your code should look like this. It should be very easy to tell what exactly is going on. So what did we learn? Don't do what I did. Don't do 33 commits in one day and then 0 the rest of the week. That's not a good way to run your life. That's not a good way to run your project. You wouldn't spend 33 hours working, in one day. One, because it's impossible, and two, because that sounds like a bad time. Split your goals into little problems. So if you have this big feature, you have this big milestone, make sure that you're working on individual bits of it, because that's going to help you in the long term. Make sure you can get to that end goal. Also, test your code. Please do it. It'll help you. It'll make everyone else happy, and document it as well as automate. So what is Bifrost? Well, I talked a little about my entire dev process, but what is this tool I made? It's a Flask-based HTTPS C2. If you don't know what a C2 is, basically it's this concept where you have a central server and then a bunch of different implants, I call them agents, talking back and forth between that server. And you're sending commands, they're executing it or doing whatever, and then they'll send that input back. And basically it's a way in which you can manage a bunch of different malware across a whole host of machines. So there are 4 main components to it. There's a reverse proxy. Imagine this just basically as a middleman between the end user and your backend. Essentially, I can manipulate requests, I can add encryption, all kinds of stuff like that. It's pretty cool. The one I'm using is Nginx, so if you want to look that up. I have the Flask app, which I've talked about. This is basically just a Python web framework, and then a DB backend, and then agent on your laptop. So this is what it looks like. Features. I have full TLS encryption on all of my communications. So if you pull up the Wireshark capture, it's not going to be in plain text like that. It's just going to be a whole bunch of gibberish in HTTPS. There's a fully integrated pwn board. So one of the cooler things we have on the red team, if you go to ritsec/red team on GitHub, so you have this thing called the pwn board. This is built into my tool. And you can actually click on, see every single one of those are links. That'll pop you open into a asynchronous reverse shell. And you're able to run essentially jobs and get output back from that. Every single one of the agents is malleable. So say I am in a different competition. I want my agent to be less noisy. I want it to call back every 5 minutes instead of every millisecond. I can set that. I can also set a whole bunch of callback IPs. So say I want to talk to multiple C2 servers besides my own. We can definitely do that as well. So here's what the reverse shell looks like. This was all made in JavaScript, actually. I know, if you worked in JS, that's pretty annoying. I'm kind of a beginner, but I was able to do this. And basically, you can run commands. It'll start a new job, and then you can get the input back on the next command. So it works asynchronously like that. So here's the typical flow. Basically, an agent registers itself with the server. It gets back a agent ID. So the backend database is going to make a new entry called agent, IP, operating system, all that kind of info. It's going to have a primary key that's basically a unique identifier for that specific one. It's going to get that. And so every time it makes a call back to the server where it's looking for jobs, looking for commands, what can I do? It's going to send over its unique identifier so the backend database can know, specifically this is the agent I'm talking to. I'm going to send it back this command. And then your user is going to make new commands in that reverse shell as we were talking about. And then it's going to make a new entry in the DB with that specific command ID. And then an agent's just going to pull it. So we also have some other fun stuff. So there's some bash payloads. The one called Bingus, that's basically a bunch of new users we make. They all have root login, and they also have a unique SSH key that I've stolen and generated locally on the machine. There's also a script that will rewrite the SSH config to make sure that my users can continue to log in with that key. It just runs every so often and changes literally one word in the config. Pretty funny. We also have some cron jobs. So those are basically, if you don't know what a cron job is, it's just something that runs every so often in the background. You can set it and forget it. I have one actually working as a dropper. And then there's some other fun stuff as well. What is a dropper? If you don't know what that is, basically it's just a little piece of code you put on something. It could be like one line, and it'll fetch out your malware and then run it on the system. So it's this intermediary step. We have some malicious services. Systemd journal, systemd printer. If you see this on your system, that's not an actual systemd service. You can look it up. That's me. And both of those are monitoring various like implants on the machine, as well as some other fun stuff. And then there's also a stealth script. So this will remove all the log files on the system. It's kind of mean, but it's funny. And then the idea is to basically integrate all of these. This isn't done now, but integrate those all into the terminal session. So you can just say stealth, and it'll tell the implant basically, pull all the stealth scripts, run them, stuff like that. So some future ideas, just stuff I want to add. I want to add a modular breaker library. So we have these things in Red Team called breaks. Basically, when you're in a competition and one of your services go down, that's one of our standardized breaks happening. So turning off ping, wiping all your IP tables rules, all that kind of fun stuff. I want to have a big library of them. So it's modular, and you can just plug and play. More listeners, so DNS over HTTPS. Raw sockets, SFTP, that's all encrypted, except raw sockets, but it's pretty cool. Stuff like agent chaining. So one of the cooler things you'll find in some industry C2s, command control frameworks, is this thing called beacon chaining. Specifically, Cobalt Strike has a really cool one where, say I have access to this box, and I have an implant on this box. These two can talk to each other, but my C2 can't talk directly to this machine. So it's a way of basically getting your commands to that machine that you can't directly talk to by having your agents talk to each other, which is pretty cool. I think that'd be fun to write. Other things are built-in persistence, so more ways in which I can keep myself on the box. Some stagers as well, more droppers, more ways to get my malware on the machine. And then from a development side, writing up like a full CI/CD pipeline. So right now, one of the issues I'm having in dev is I have everything containerized, but every time I make a change, I have to make a new Docker container. And that can be kind of annoying. It can take a lot of time. It's a lot of manual commands I have to do. So setting up like an automated system through something like Jenkins, which you can look up, is pretty cool. I feel like that'd be a good way to do it. Also some Windows-specific stuff. So right now it's pretty Linux-heavy, but I think implementing stuff like reflective DLL injection or process injection would be pretty cool. And then maybe like a Ragnarok button. So at the end of every single comp, you'll just have an entire red board. There will be no services up. I want a button that just like does that. I think it'd be pretty funny. Just break everything. Yeah, so here's my contact info, LinkedIn, GitHub. You should go follow them. There's some cool stuff on there. And yeah, any questions? Anthony.
I don't really know how to phrase this. But so red team recruiting, that's like where you kind of started with the C2, right?
Yeah.
Do you think going from like the red team recruiting to red team like pipeline, was that kind of a goal, or did that kind of happen? Or?
Me personally?
Yeah.
So I was lucky enough to be with two of our alumni. Their names are Enzo De Stefano and Jake McLennan. And both of them were super into red team. So my entire experience was basically talking to them, being super excited about making malware. And so that was something I found that I really enjoyed. I also found that I really liked writing software. Not only that, but just like offensive software, malware, stuff like that. So RCR was definitely a big component of that. I think it definitely helped becoming a red teamer. Yeah.
And then was all like the really cool stuff just kind of like let me Google like the real cool C2s and then just add them for myself, or was that?
Yeah, so actually what I did when I was trying to find features, this is this really cool thing, MITRE attack framework. If you go in there and then you look at the C2 techniques, you can find this entire list of articles, and it talks about APT C2s and what they're actually doing. And so I would read through those reports, and I would be like, oh, this is really cool. I want to implement this, or this is really, really, really cool. Let's make this a feature sometime down the line. So that's how I got all of my features. That's actually why I had HTTPS listener initially. Also because Covenant had that. So I'd look at Cobalt Strike Covenant, see features they had, and try and emulate those in my own. That's the best way to learn. Just look at people that are better than you and copy what they're doing. Chinese C2s. Wrap it up. Any other questions? Tanshi.
I know that you're trying to move on to Windows stuff.
Yeah.
Are you going to be writing that in Python,
So personally, personally I don't really like writing C++, so I'd probably try and do something else. But C++ seems to be a necessary evil when working with Windows, so we'll probably be doing that. I'll cry about it.
I mean, you can write stuff for Windows.
There's the really nice Win API Python library. I mean, there's different ways to do it. If you want it to be fast and native, though, C++. Yeah. Joe? Write in Rust. What a nerd. Boo the Rust nerd. No, I'm joking. Rust is great. Anyone else? All right. Thank you, guys. Appreciate it.